All right. Hey, look at this. Golang co-creator Rob Pike says what we got right and what we got wrong. I'm into this. Because remember, we're kind of in that mode right now where we're going through. Remember, this is 2024, the year of Golang for me. I'm going to give it Golang minimum 1 year of full effort on all side projects I can to see, can I love Golang? Now, I will be real for a quick second. My Golang thing started technically in February. In January/December, I did write one more tool at Netflix with a bunch of Rust, and it was fine. But now I'm going to, now it's just go from here on out for a while. All right, Golang co-creator Rob Pike, what we got right and wrong. I'm curious what he thinks they got wrong. All right, an excellent standard library and packaging system. Well, I mean, packaging system did kind of come a little bit. First-class concurrency support and a focus on readability among the traits that keep Go devs happy. I will say one quick thing, even though we haven't even started, a quick don't let them cook. I got an opinion instead. Golang devs, stop with the one-letter variables. What the hell is this? What world do we live in? Like, you know, like if we go like this, WebSockets, Garia. All right, if we do WebSockets Garia, where are you? GitHub. All right, please. Okay, I know WebSockets. I can tell you all about the RFC. I know it pretty well. I'm pretty good at it. I know I could do all this stuff. Let's see, they have compression, client, Go, sums, join, mass, prepare, proxy, Go, server, test. Which one's going to do the actual thing here? Let's just go in here, and I'm just going to look for this, 126. That should be probably good enough for me to be able to find it. There we go. Connection, found what I'm looking for. There we go. All right. So here, okay, so let's look at what we got here. We got W final bool C, W.C equals C, like what the hell are we looking at? What am I looking at? I'm pretty good with Go, but why do you got so many one-letter variables? Why are these all one letter? Pretty much stop this. What the hell's W? Why are we doing this to ourselves? What happened in here? Why you gotta do this? Why you gotta do that? Just do like this N's and P's and shit. Just, yo, dog, just stop it. Stop it. When you do this, if you name a variable NN, you get the length of P and you get NN out of there, your shit's fucked up, okay? You done messed up, Blocky. It's time to get the hell out of here. Okay, I hate that. I literally hate this. By the way, one does not simply get the length of P. Okay, I just want you to know that. One does not simply, really, L take. Oh my goodness, you got, okay, hit me. Why is it an L take? Flip turtle, why is this an L take? Come on. Yeah, okay, double N is too far. I agree with you. Double N is too far. Come on, because dark mode, no one cares. Dude, what? Damn it, Flip. You can't just meme me from a previous video, okay? This is supposed to be a live interaction piece, okay? Dang it. Flip, take this part out, okay? You don't, Flip, take Flip out. Flip, you take Flip out right now. This is bullshit. Anyways, let's see right here. All right, okay. Now we're not done doing this. There was a treat for attendees at Gophercon AU in Sydney, Australia, the city where Go's specification was first drafted. Original Go co-designer Rob Pike gave a talk commemorating the 14th anniversary of the day the Go programming language launched, with a talk looking back on what we got right and what we got wrong. By the way, Go, 14 years old. Like, that's all right. I like it. You know, I like HTMX, has roots all the way back into the 90s. I'm liking Go. It has roots all the way back to 2010. I kind of feel like I'm starting to like old things, right? And Go's just pretty much nice C. That's all Go is. Go is just convenient C. That's how I look at Go. Pike began by remembering watching as the website first went live on November 10th, 2009. The whole world learned what we'd been up to. Boomer confirmed. Absolutely. Boomer energy coming out of here. 14 years later, there is much to look back on, Pike told his audience, promising to explore larger lessons learned. Pike emphasized he was speaking for himself and not the Go team or Google. Go was and still is a huge effort by a dedicated team and a huge community. But he went on to deliver a talk sharing lots of insider memories about the early history of Go, along with some useful insights on what's important. Okay, awesome. What's the takeaways? Give me the takeaways, people. Go's 5 original creators discussed what made Go popular for a 2022 article in Communications of the AMC. In the article, Pike joined with Ken Thompson, Russ Cox, Robert Gressimer, and Ian Lance Taylor to point out that Go was specifically designed for concurrency and parallelism, leveraging the power of new multi-core chips while handling at-scale workloads. Yeah, I would say that this is Go's greatest achievement is their concurrency model. I know Elixir fanboys are going to tell me I'm wrong, that Elixir's better, okay? I don't know Elixir well enough to say that it's better, okay? But I absolutely think Go has one of the greatest. AMC mentioned, bye. This is ACM. Academic computing machinery. What does it stand for? Magazine? Is it magazine or machinery? What is it again? Anyways, I used to participate in ACM competitions. Won a regional one once. It was awesome. Elixir mentioned and get banned. But they also credited Go's ongoing development-focused philosophy for its success, as well as thriving community and its contributions. Yep. It's a new theme Pike revisited in his November talk. Our original goal was not to create a new programming language. It was to create a better way to write software. If it didn't take 45 minutes to build the binary I was working on at the time, Go would have not happened. I love this, by the way. This is the greatest reason to do something, is when you are massively inconvenienced by something. And this is real. This is genuinely real. Right now, there are multiple companies with large enough JavaScript libraries and code bases that it takes over 10 minutes to build the thing the first time. You should just take a moment and sit down and think about what you've done. When this happens, you need to rethink about why you are at the position you're at, because it is a huge inconvenience to have this, right? If you're doing C++ stuff, why is it happening, right? C++ is unfortunate. It is the way it is. I don't think you're ever going to get out of that. Apparently, mold makes it a lot better. Soon Pike was sharing with the audience his detailed list of things we got right. Each was crucial to the ultimate success of Go. For example, they made sure Go was easy to parse, which in turn made it easy to create tools like IDEs, as well as Go's official language server, Go Please. Yeah, this was, by the way, this was like the 10,000. Again, this is why I largely think TypeScript has been so successful in comparison to something like Flow, is because when you make a language and you make the tools around the language as a requirement, everything will adopt it so much faster. Flow is not good. I know nothing about Flow other than it was the alternative to TypeScript, but it did not have all of the bells and whistles that TypeScript had with all the developer tools. And so my imaginations is that Flow probably does now have those things, and maybe it's still not that good. But, Flow tooling still sucks ass? Yeah. See, yeah. There you go. Tools make things so much better. This is and Go Please is actually a really incredible LSP. If you go and use it, what you'll find is that the LSP has almost Copilot-like autocompletion, because it won't just autocomplete what you're doing. It will also autocomplete one or two steps ahead in the LSP itself. It's very impressive LSP. It's a huge W LSP. It's probably my favorite LSP out of all of them, including Rust Analyzer. It's really, really, really good. As soon as they were augmenting the compiler with tools for automating testing and code vetting, not to mention package compiling Go command, but that wasn't the only thing Go got right. Pike also applauds the Go format auto-formatting tool, partly because the guts of the tool became a library that could reuse in simpler simplifiers, analyzers, and tools verifying the crucial code is covered by testing suites. I will say one thing I love, again, about Go format and the fact that it's a language decision. I don't like the formatting decisions Go went with, but I like that they went with a decision. And the reason being is that Go used JavaScript and said, any tool, what you got to remember is that any tool that does these formatters and these linters, there's somebody behind the scenes that is working an incredible amount of effort to make these tools work, because they're not opinionated and they're all third party. Making a prettifier work within a editor is shockingly difficult. And you may not realize this, but what is it? NullLS? NullLS finally just gave up. Was just it's too hard to manage all these different things. And it's because it is really, really, really difficult. And so having your builder, your formatter, your LSP all being owned by all the same thing, it makes it amazing. None LS exists, though. It does exist, but it's still you got to remember that none LS was birthed out of actual tears, not fake tears, real actual tears of really hard times. Someone quit open source because of how hard it is. Yeah, it's not that none LS is somehow doing it better. None LS is just literally falling on the sword. That's all. Not to mention that the output of these tools could always be perfectly formatted for humans and for machines. The time saved by not arguing over spaces and new lines is worth all the time spent defining a standard format and writing this rather difficult piece of code to automate it. Interestingly, Go's package library grew somewhat as an accident, as there was no other place to install Go code at the beginning. Yeah, if you used Go during the early years, there was no packaging system, right? It was kind of it kind of sucked. Like during those early days, that was like not very great. I think that actually stunted a lot of Go's growth to begin with, was their early days. They really goofed that up, but they really kind of turned it. Yeah, GoPath sucked balls. It did. It absolutely did. It was so crazy that you had to do that. I mean, I understand the reason for it. It's smart. It's like, hey, we don't need to have a version manager. You just say what your path is and it works. But it's just like, no, that sucks. Trust me. That sucks. But now Pike sees it another thing Go got right. The existence of a solid, well-made library with most of what one needed to write 21st century server code was a major asset. It kept the community all working within the same toolkit until we had experience enough to understand what else should be made available. Another great thing about Go's standard library, there's really everything you need in the standard library. Like you can use these other things, but just, you know what I mean? But just the standard library alone, you could build pretty great applications just using standard library. No dependencies. It's shocking how far you can get. Another thing Go got right was its release of a formal specification. Not only does that lock down behavior when writing a compiler, it enables multiple implementations to coexist and agree that on that behavior. In turn, this in turn helped refine the language, Pike says, and to fine-tune its specification. Let's go. Go install shit at home Go, not following Linux XDG base directory specification. Yeah, but XDG I don't think existed when Go started. So it's kind of like, do you break how Go works because something else changed underneath it? You got to remember that Go started November, 2009. That's before XDG home, right? If I'm not mistaken, I'm pretty sure that's before XDG got started. Am I correct on that? I can't remember when that started. XDG is 2000? Oh, it's 2000? Oh, shit. Okay, well, my bad then, yeah. 2009, yeah, I know. Okay, then yeah, Go sucked. Go, you should have used local. Come on, Go. Get your shit together. All right. Early on, Go issued a compatibility guarantee producing a dramatic documented effect on the language's uptake, Pike says. So much so that I find it puzzling that many other projects have resisted doing this. I'm not really sure what they're trying to say here. Issued a compatibility guarantee. Oh, yeah. Okay, yeah. Compatibility guarantee, meaning the language will not be breaking backwards compatible. Okay, yeah. That's good. Pike also added, as an aside, that it didn't hurt that Go acquired a reputation for fast builds. Yeah, I'd still say that this is Go's biggest thing that I hear a lot about is fast builds. What Go left out, Pike also gave the audience a glimpse at the feature that never made it in, but he wished it had, allowing arbitrary precision integers, which he said would have eliminated an entire class of security concerns. In a world where long integers can exceed the allocated memory, there's still a debate going on about how we handle integer overflow. Well, what if they don't overflow? You don't have to think about it at all. The runtime cost would be low, and we just wish that I'd thought of it in time and done it. People may have objected. It looks too expensive, but what it frees up is amazing. You just don't think about integer overflows anymore. Interesting. I guess I've never. I don't know. I've never in my head thought about this. So what it's saying is that let's just say you had this, right? You jump into Node and I got const a equals 232 minus 1, right? So we're really, really big. So if I go a plus 1, a plus 2, in some world, this would cause a problem. Like if I was a 32-bit integer, this would cause a problem. So if I go like this, we get ourselves a problem, right? Because I just overflowed. I went back to the beginning, right? Oopsie daisy. And so if the compiler just took care of that and said, you no longer fit within a 32, you're now a 64, I could see why people would like that. But to be real, the only times I think about the size of an integer is when I am doing like specific sized integer tasks, which makes it really, really hard for me to kind of reason about why I'd want this. Does that make sense? Exactly. Well, because the only time implicit is, I don't think implicit is the devil. I think that the right set of implicit operations is really, really nice. Right? I mean, to be really fair, when you do a heap allocation, it's implicit on where it goes. It's not like you actually align your own heap and how the allocation strategy works. You know, like there is some level of implicit that you do care, like that you just don't care about. Doing protocols would be crazy. Exactly. So that's what I'm thinking about on Dono, is that exact same thing, which is what would happen if you're trying to do a protocol in which you have a specific byte size that you want to fit and you accidentally roll stuff over. Right? It would be, so I'm not sure if I think this is a great idea, but maybe I understand it, but maybe I don't. I'm not sure. Later, he says he'd like to see the compiler do more automatic checking of Go's dynamic interfaces and also checking for the possibility of stalled progress, deadlocks that could cause resource sharing. Anything that makes your program safer at compile time is good, although he wouldn't want insufferably long compile times. Rust mentioned. This is definitely a Rust mentioned moment. This is fantastic. This is fantastic. Like, I'm actually on his team, which is why I would love to see an option type introduced. Like, I would love to see an option type introduced into Go that is fully supported. So, or the ability to say, all nils I expect to be options. Like some sort of like, you know how they have like some Go experimental behavior? It's like you can remain in the standard Go way, but you can also opt into the option side. I would love to see that. The oddities of Go compiler. One other crucial thing that Go got right, according to Pike, was its portability. That is, making it easy to compile code for other platforms. It was made possible by Ken Thompson's compiler. Written in C programming language, even though others argued that the compiler should have been written in Go itself or using tools in LLVM. Pike acknowledges Thompson's compiler was an odd duck, using old ideas in compiler writing, albeit modestly sized, as well as pragmatic and efficient. But best of all, it was familiar to us, which made it easy to make changes quickly as we tried new ideas. Doing it our way, however unorthodox, helped us move fast. Some people were offended by this choice, but it was the right one for us at the time. This is super cool. This is such like a cool statement. This is such a cool statement. You know, I mean, you can really replay this statement in a lot of modern contexts. How often are you told you need to do something a specific way, and that is the only way to be successful? Like, I recently saw somebody say that if you teach somebody who is new to programming, if you don't teach them to do React, you are setting them up to be a failure. Right? Which is a very, very limited view on just programming in general. And so it's just like when people, you know, there's good wisdom in listening to what people should do and how you should do things. But there's also good wisdom in not doing whatever the current prevailing wisdom is, if that makes sense. You know? And so I like this. You got, you know, obviously it takes wisdom. Someone like Pike, probably smart enough to make that kind of trade-off. If you're new to programming, it's really hard for you to make that trade-off because you don't even know what you don't know. You don't even know what you won't know in 10 years. Like, you are a decade away from being there. In 2005, Russ Cox had written a tool translate the compiler semi-automatically from C to Go. And of course, today, there is an LLVM hosted compiler for Go and many others, as there should be. The unknown unknowns. Oh yeah, don't make me get into the unknown knowns. Like that's, you know, we get into the weird part. Pike's list of what Go got right started surprisingly with Go's mascot, an unnamed cartoon gopher that he called one of the earliest factors in Go's success. Really, that's actually been one of the largest barriers for me. I think I don't care. I don't want a mascot. Pike truly believes it was vital to Go's growth, having a recognizable, funny creature that the community could rally around. Its goofy yet intelligent demeanor. Okay, I would never use the term intelligent demeanor to describe the gopher. Its eyes are semi-cockeyed. Okay? Look at those eyeballs. Like, that's not intelligent demeanor. Okay? I mean, there's a lot of words for it. But usually, like, we don't typically we don't typically associate wisdom and intelligence with being cockeyed. Whether or not that's, you know, that could be completely unfounded bias, but that's what it is. You know what I mean? That's just what it is. He can build anything, sets the tone for the community engagement with the project. One of the technical excellence allied with real fun. I mean, I do like the idea of real fun, so maybe I'm just being too harsh on this one. Yet one design or one decision that was perhaps not the best choice was releasing the Gopher's design under Creative Commons Attributions license. On the one hand, it encouraged people to remix them in all fun ways, Pike acknowledged, which in turn helped foster the community spirit. Why was this not the best way? This is the best way. What are you talking about? You don't want to be like Rust. Rust is a bunch of dummies, right? Dude, Rust Foundation was so stupid in their decisions that they literally tried to sell releasing Ferris as open to the community as like positive in their decision. And it's like, guess what? They didn't even have a choice in it. They just made it sound like it was good on their behalf. Rule 34 exists. Rule 34 does not exist because people give you permission. By the very definition of Rule 34, it exists without your permission. All right, let him cook. I'm going to let him cook. Let's see. It's a gopher cuddling up to the engineer. Sucking on the toes. Look at that guy. Look at that guy sucking on the toes. Look at that. Look at that gopher sucking on the toes. That's just what happens. But Pike says there were also frustrating arguments to correct attribution or misattributions. And to be honest, the attribution was often honored only reluctantly or not at all. I mean, can somebody tell me who drew Ferris? Like, it's tough. You know, it's tough. All right, so if we're going to do it over, we'd think hard about the best way to make sure the mascot stays true to his ideals. Cool story, bro. That's who cares? Honestly, I don't. Maybe it's unfair for me not to care because I'm just not in that position to care, but I don't care. The Gopher was Renee French, Pike's long-term partner. Oh, so there's a bit of a personal thing. Renee's feeling slightly slighted because of non-attribution for it. Pike's talk culminated with Go's most impactful decision, but he started by describing what the world was like in 2002 when he'd first joined Google. Google had seemed to be avoiding the concurrent execution of process threads, if not pretty much banning them outright, Pike remembers, which bothered him. I've been doing concurrency-like things somewhat without even realizing it since 1970s. All right, in 2002, there were many people who believed threads were a bad idea, but that's also a wild, dude, what is this take? Okay, we just got to look at this for a second. Why threads are a bad idea for most purposes. Okay, I guess this is something we should I would love to look at some point, but this seems it just feels like a wild take, right? I gotta go see that. You know what I mean? It just hadn't caught the mainstream idea yet. Go was born partly to address that. It ends up being one of the biggest things that Go got right. Nowadays, most mainstream languages have good support for concurrency, Pike noted, but at the time it made Go seemed like something new. Go support for concurrency was a major attractor that helped grow early adoption, pulling in programmers that hadn't used concurrency before but were intrigued by its possibilities. Pike believes they absolutely succeeded. Go helped popularize concurrency as a way to structure server software, although he admits that it might have been less impressive to programmers who weren't tackling intrinsically parallel problems like serving HTTP requests. I think one thing that's not being mentioned here is Go was way earlier than a lot of the async ways you would do stuff, like async await or even promise proposal. When did promise proposal even come out? Promise proposal date, right? Like, when did it come out? Does anyone know? Oh my goodness. Spec promise proposal date. Does anyone know when this thing, can someone just help me find this? Someone go find this. When did it come out? When did it come out? I don't know when it came out. But either way, this is, the fact that we're starting off with the stupid gopher as the reason, for a huge reason vital for its growth, I would argue deeply that this right here is the biggest reason for Go's growth, is that it has perhaps it has the greatest async model that I have seen, or the greatest concurrency model that I have ever seen personally. JavaScript promises were introduced June 2015 with the release of ECMAScript 2015. Yeah, but promises were before that. 2012 for promises in JS. Yeah, okay. But either way, Almost as good as JavaScript async model. Dude, that's like offensive that you would say that. It is significantly better. And if you don't understand why, I say this all the time. I mean, we've talked too much about this, but I will say it one last time. Ryan Winchester, let's go pull up Ryan Winchester. Dude, I hate the fact that I like Ryan and it just never auto-completes for him. Here we go. This right here. This is why async sucks. This exact reason right here. This is it. This thing. You know what I mean? The thing. If you don't get it, you don't get it. Soon, Pike's talk arrived at his grand conclusion. Here are 14 years after the launch, and it's fair to say that overall it's a pretty good place. Pike succinctly summarized other factors in their success. Okay, we can talk about this at some point. We got here partly because of a strong standard library that implements most basic needs for server code, concurrency as a first-class component of the language, an approach based on composition rather than inheritance, a packaging model that clarifies dependency management, integrated fast build and testing tools, rigorous consistent formatting, focus on readability over cleverness, a compatibility guarantee. Now, a lot of you may not realize this. This was not the zeitgeist in 2009. Okay, the zeitgeist in that time. This was like the pinnacle of Java fever. I don't think people realize how like against the grain Go was at this point. And so it's absolutely amazing to see this come out at this time. Because the thing is that a lot of people want functional languages to be successful, and they think functional stuff is the best. The problem with functional stuff is that you go against the grain so hard, if that makes sense. It's so different. It's so different from what people are used to that it's hard for people to want to even begin using it. But Go didn't do that. Go said, okay, functions are first-class citizens. You can do all the functional things you wish to, you kind of could do, but it's like a really limited type system, so you can't quite do a lot of functional stuff. But functions are first-class citizens, and you can curry if you want to. But nonetheless, this right here is just awesome, right? This is just awesome to be here at that early. Absolutely love it. And that's why I think people got into, that's why people were able to get into it so easy. And most of all, because of the support of an unbelievably helpful and diverse community of Gophers. Perhaps the most interesting consequence of these matters is that Go code looks and works the same regardless of who's writing it, is largely free of factions using different subsets of the language, and is guaranteed to continue to compile and run as time goes on. That may be the first major that may be a first for a major programming language. I think my guess is that Lisp might have something to say about that. We definitely got that right. This is great, though. This is the greatest part of Go. This might be the greatest part of Go. By the way, the full talk is like an hour, or else we would have done that. Lisp mentioned, let's go. This is great for real, by the way. There's crazy factions in Lisp, though. This is true. Lisp may not have changed much. It's very Lindy, as people say, but it is most certainly, like, Lisp is your own programming language, as far as I've understood it. You create it the way you want to. The full talk is good. Yeah, I'd love to. I'll probably listen to the full talk on my own. It's just that usually full talks I can't do like a lot of thoughts on because you just want to let the person cook. You know what I mean? It's a little different. Usually full talks, you want to let them cook. Anyways, this is fantastic. I agree with every part but the Gopher part. Gopher part seems a little weird. But the concurrency, like testing, people again don't realize how important testing was. There was no, like, testing it's just not there. You know what I mean? Testing was not there at all. And so to have testing as a part of something, to be intrinsically a part of the language, incredible. To have a build tool that is a part of the language was incredible. Like, Java almost got that right. But Java, like, to successfully build Java, you need a degree in Maven, which is just like, or Ant, which is very, very difficult. You had to use NetBeans. Anyways, Rust came in and Rust took a lot of these ideas. You know what I mean? And Rust was smart to take a lot of these ideas. Like, this is smart. This is what you should do. All right. Hey, the name. It's the Primogen.